Well, hey there kiddos, and here is your video on Laws of Exponents Day 2. Today we're going to talk about multiplying things that have exponents. And so we're going to do two more rules on the back of your agenda page where you wrote some stuff down yesterday. The first one is this one. It's called a product of powers. It's when you have the same base, so they both have a base of a, but you have different exponents and you're multiplying them. So a to the m times a to the n. And so when you have a product of powers, so you're multiplying two things that have exponents together, what you actually do is you add the exponents but multiply coefficients. So you will keep the base the same, whatever the base happens to be. In this case it's an a, and then you'll add the two exponents m plus n. If there happen to be coefficients other than 1 in front of the numbers, you would multiply those coefficients. And so what I like to always tell my kids is that you need to multiply the big numbers, size-wise, not quantity-wise, but multiply the big numbers, add the little numbers. So big numbers are coefficients, little numbers are exponents. Multiply coefficients, add exponents. So here's an example. If I were going to multiply these together, I would multiply my coefficients. 5 times 6 makes 30. My base is in x because that's where the exponent is on the x's. And then I would add these two exponents. 2 plus 7 makes 9. So that would be the product of powers. Now the next one would be this one down here. This power of a power is when you have a single base to an exponent taken to another exponent. So you have a single base with more than one exponent. And when you have this kind of a problem, instead of adding exponents like we did when we just multiply them together, when we have a single base with two exponents, we have to multiply the exponents. So we're going to multiply these two exponents together. So I would keep the base a and multiply my m times n and get mn. So for example, this one right here, I have x squared to the third power, so my base is in x, and I've got to multiply the two exponents. 2 times 3 makes 6. And so there's one more, although it's very similar to the one we just did. It's called power of a product. It's when you have multiple bases all taken to a single exponent. So you have a times b, but the whole thing is to a power of m. So you've got this exponent outside these parentheses all by itself. And when you have a problem like this, you take the exponent outside and you have to distribute it to everything inside. So distribution means multiplication. So it's very similar to this problem, you just have more than one base. So for example, this ab to the power of m would become a to the m and b to the m, because you have to distribute that m to everything. So we're going to distribute the exponent to every single part. That would include coefficients if you had coefficients in the problem. So here we go. I have xy squared to the third power. So I've got to distribute this 3 to the x and to the y. And so when I distribute it to the x, it becomes x to the third power. There's an invisible 1 right here, and 1 times 3 makes 3. Then y squared, when I distribute those two exponents, becomes y to the 6th power. So that's simplified. So those are the three rules we're going to deal with today. So let's practice simplifying some expressions. So 1 and 2 are just going to use the product rule. So I'm going to multiply coefficients, add exponents, because I'm going to have multiple bases that are the same. And so I want to add the exponents. So here, this is like having a 1q squared times 2q to the 4th. We'll multiply coefficients. 1 times 2 makes 2. Keep the base, and then add the exponents. 2 plus 4 is 6. So pause just a second, try number 2, and then come back and check it. So you'd multiply coefficients. Negative 2 times 6 becomes negative 12. Excuse me. And then your base is a u. Add your exponents. 2 plus 6 makes 8. So the next couple are using the power rule. And so I have a power to another power. So this is where I have a single base to an exponent. So I have to just multiply the exponents, okay? But I also have to take this exponent and distribute it to everything inside, which means I have to distribute this exponent to the 2 and to the a, because both of them are in parentheses, both of them are to the 4th power. So when I do number 3, this really becomes 2 to the 4th power. And then for the a, I will multiply my exponents, making a 12. Now to simplify this all the way, I've got to figure out what 2 to the 4th is. You can type that in your calculator, or you can do 2 times 2 times 2 times 2, which is 16a to the 12th. This is the simplified version. If you leave a number with an exponent on it, you're not simplified all the way. So now number 4 here, I've got a number outside parentheses, then I've got parentheses, and then I've got an exponent. Well, let's talk order of operations. It says parentheses first. So I've got a D, and then it says exponents. So I have got to deal with this exponent and this set of parentheses before I can deal with this 3. So this 3 is going to happen at the very end. So my problem is going to end up 3 times something, and I'm going to have to distribute this 4 out here to this 4 and to my y. So this becomes 4 to the 4th power, and then y to the 24th power, because I want to multiply them. Well, I'm going to figure out what 4 to the 4th power is. So I'll just grab my calculator and I will type 4 to the 4th power, and I get that that's 256. So I have 3 times 256 y to the 24th. Well, to finish simplifying, I've got to multiply that times 3. So times 3, and I get 768 y to the 24th. That is the completely simplified version, and that's what you're being asked for. So now we have a few more. These are very similar to the ones that we just dealt with. Okay, so I have power of a product, and I've got lots of things happening, but I'm going to have to distribute this exponent outside the parentheses to everything inside, just like I did with 3 and 4. But number 5 here has a fraction, which means I have to distribute it to the numerator and to the denominator of that fraction, as well as to the x and to the y. So I've got to distribute several times. So I'm going to distribute here, so it becomes 2 to the 3rd over 3 to the 3rd. Then for my bases, I'll multiply exponents, so x to the 6th and y to the 9th. And then I'll simplify my fraction here. 2 to the 3rd is 8. 3 to the 3rd is 27. X to the 6th, y to the 9th. There's your simplified expression. Now number 6. We happen to have an exponent that is a fraction. That's okay. That's acceptable. We're going to talk more later about what that really means, because it does have a meaning. But for now, we're just going to do what we've been doing. We're going to distribute. So we're going to multiply all of our exponents. Luckily, there are no coefficients here to deal with. So I have x. 12 times a half becomes 6. 4 times a half is 2, and 6 times a half is 3. So that's what that becomes. That's your simplified expression. So let's look at a couple more. Now let's apply it to some actual problems like area of a triangle and of a square. So you're supposed to express the area of the triangle as a monomial. Monomial is a word we haven't discussed yet. This right here is a monomial. Okay, it's just a product of numbers and variables is all it is. Has no plus signs, no minus signs, just a product of numbers and variables. They even give you the formula for the area of a triangle. It's 1/2 base times height, or base times height divided by 2. So if I want to find the area of this triangle, I've got to take the base, which is 5c to the 3rd d, times the height, which is 8c squared d to the 4th. And I have to divide that all by 2. So I'm going to take care of the numerator first. There are no exponents outside the parentheses, so this is strictly just a multiplication problem. So I'm going to multiply coefficients, add exponents. So when I multiply my coefficients, 5 times 8 makes 40. Then my c, when I add my exponents, 3 plus 2 is 5. And for my d, when I add my exponents, there is an invisible 1 on this d, and you need to remember that it's there, because if you don't add it, you'll get the problem wrong. So when I add my exponents, 1 plus 4 makes 5. And now I have to divide that all by 2, which just means I'm going to divide 40 by 2. Well, 40 divided by 2 is 20, c to the 5th, d to the 5th. This is the area of that triangle expressed as a monomial. So number 8 asks which expression best expresses the area of this square. Well, the area of a square, to find the area of a square, you just take the length of a side and you square it, because it's side times side. Well, I know how long a side is. A side is going to be 3x squared y squared, and I've got to square that. So now I've got an exponent hanging outside the parentheses, so this means distributed to everything. So I got to distribute it to the 3, to the x, and to the y. So when I distribute it to the 3, I get 3 squared. And then when I do the x, I will multiply my exponents and get x to the 4th. And with the y, I will also get y to the 4th. And then to simplify that, 3 squared becomes 9 and then I have x to the fourth, y to the fourth, and so if you look at your answer choices, A is the one that best represents it. So that is multiplying with exponents. There's 3 ways you're going to see it. One way is when you have more than one of the same base and you add your exponents together because you're multiplying more than one of the same base. Another is when you have a single base taken to a power, taken to another power. So if you've got a single little exponent hanging outside parentheses by itself, it means you're going to have to multiply the exponents. And if you have multiple things in the parentheses, you'll have to distribute the exponent to everything in the parentheses and then simplify from there. So that's what we will practice when you guys come to class tomorrow. I will see you then.